Okay, we are on to 3.2, Systems of Inequalities. Last section we were working with equations with two variables. Now we're going to be working with inequalities with two variables. Before we get there, let's remember how to graph a line from slope-intercept form. Last year, you guys should have done a lot of this. I know you did do a lot of this. Graphing y equals mx plus b. We know that m is our slope and b is our y-intercept. When you graph, you are going to start with your y-intercept. Okay, so if we have something in mx plus b form, your last number is your y-intercept. So you go on your y-axis to -4, 1, 2, 3, 4, and you place a point. From that point, you're going to count out your slope. We want slope to be in fraction form, so we make it 3/1. And the top number will tell you how to move up and down, your rise, and the bottom number tells you how to move left to right, your run. So 3/1, we would go up 3, right 1, and place a point. And then you can draw in your line. Hopefully you do a better job there because I kind of missed that point. Okay, pause the video and you guys do 2, 3, and 4. Okay, check out what I have. This number 2, your y-intercept is 1, and then your slope is -2/1, so down 2, right 1. Numbers 3 and 4 are kind of like some special cases, and I gave you some hints right here. If you don't know these, you might want to jot them down into your notes. Horizontal lines always have the equation y equals a number, because it's telling you that every y value has to equal 2. Well, if I look at the line that I just graphed, every single point on it, every single one has a y value of 2, and so it makes a horizontal line. Likewise, for x equals -3, vertical lines will always have the equation x equals a number, in this case -3. Every point has a coordinate, an x coordinate of -3 on that line. Okay, this should all be a review, this slide. If it is not, if it feels like you don't remember this or that feels really difficult, come see me because you will have to do this stuff quite a bit throughout this class. So if you need some extra help on that, get it now instead of being confused all year. Okay, number 5, circle all the ordered pairs that are solutions to this inequality. This should feel very similar to what we were doing in the last section. The difference now is we're not looking for the left side to equal the right side. We're looking for the left side to be less than the entire right side. So go ahead and plug your values in and see which ones work. Okay, I got that the second and the third points work here. And you can check my work. So for 0, 0, I get 0 is less than -3. That's not true. 0 is greater than -3, so that doesn't work. For 2, 0, I ended up with 0 is less than 1. That is a true statement, so that works. And then I just continued on. You might be tempted to say the last one works, but remember, it's not an equation. We need the left side to be less than the right side. -3 is not less than -3. It's equal. So, and we don't have an equal to bar underneath that less than symbol, so that does not work. Okay, now we want to graph the inequality. Y is less than 2x minus 3. We want to graph it. I'm going to show you two different ways to do it. They both start the same way. They both begin by treating it as an equation. So if I'm looking at this as an equation, it's the same way I graphed back here. My first point goes at -3 on my y-axis. And the second point would be from counting my slope. So I would go up 2, right 1. And I'm going to do that over here as well. Okay, so same beginning. Still doing the same thing. We now need to go back and think of it as the inequality. And there's two differences in graphing equations versus inequalities. The first difference is you have to think about what kind of line to use. And by that I mean this. If you have less than or greater than, you will use a dashed line. If you have less than or equal to or greater than or equal to, you use a solid line. This is very similar from the last chapter when we were doing inequalities with one variable and we were graphing on number lines. When you have less than or greater than, you used an open dot, and when it had the equal to part, you used a closed dot. So here this is open, this line is open, there are breaks in it, but here the line is closed, it's fully completed. What this means, the closed in ones, whether it's in the line or the dot, that means you're including the points that are on the line. When it's the open pieces, you're excluding the points that are on the line. Okay? In this example, we have a less than symbol, so you would want to use a dashed line. I'm going to go ahead and use my little tool here to get a nice, neat line. Okay? The second piece or place where graphing equations is different from graphing inequalities is there is shading on an inequality graph. What this acts as is a boundary line. That boundary line separates where the solutions are versus where they are not. If you think about it, how many solutions would we be able to come up with for this? We already found 2. Would there be more? Yeah, there would be. There'd be an infinite amount of solutions. Well, we can't list all of those solutions, so we show it on this graph instead. And when we do that, we're going to have to shade in. This is where we get the 2 different ways. So the first way is to use a test point. Using a test point, you're going to pick any point you want, but it cannot be on your line. The easiest one to pick is 0, 0. Take that point and plug it in to your inequality, just like we were doing on number 5 here, which in fact we already did it. I already plugged 0, 0 in. When I plug 0, 0 in, did I get a true statement? No, I didn't. So that means 0, 0 is not a solution. If 0, 0 is not a solution, neither is anything else on this side. So that means everything on this side is. So you go in and you shade that side. Be careful when you shade that you don't, I like to do it perpendicular to the line because sometimes students will do it right over the line and then you can't tell if the line was dashed or solid. Okay, so go perpendicular so that we can still see the line. Okay? On this one, the other way to do it, so I would still need my line in here. So that's no different. The way to do this one is you can only use this way if it's in slope-intercept form with the y coming first. Okay, this one happens to be, it is y is less than 2x minus 3. And what you do here is if it's a less than symbol, you shade below. If it were a greater than symbol, you would shade above, because numbers that are below would be less than, numbers that are above would be greater. Okay, but this only works when it's in this particular setup. That is why I prefer using the test point. If you use a test point, as long as you plug it in correctly, you've got a better chance at not making a mistake. All right, but it's nice to do the test point and then kind of just verify it with this method. All right. So just another word about this. When you are graphing these inequalities, you graph them the same way you would graph an equation, and by that I mean you start with your y-intercept, then you count your slope out. But then there are 2 things you need to think about. What type of line should you use? And that's all about, does it have the equal to part or not? That's how you will know. The second thing is the shading, and that's where you're getting either use the test point or shading above or below if it's in this particular format. And then what that means is any point you pull out of the shaded region it would work in your inequality. So let's see about that. 0, 0 was not a solution, and that is correct. It's on the not a solution part. 2, 0 is a solution, and it's hard to tell, but it is under here. It is underneath your region. It is in your region that's shaded. 3, 2, 1, 2, 3, 2. Again, it's really close to the boundary, but it is in fact a solution. -1, -1 would not be, and 0, -3 is not. That is 0, -3 is on the boundary line, so you get equal, but it isn't equal in this particular case. It's just less than, so that's why that one won't work. We're not including it. We are excluding the ones that are on the boundary line. All right, graph a standard form inequality. So we talked about standard form before. It's ax plus by equals c. And the easiest way to do this is to put it into slope-intercept form. You could make a t-chart if you wanted to, and you could choose x values, plug them in to get the matching y values. But the easier thing to do is just to move it into slope-intercept form. To do that, let me rewrite it over here first. To do that, you need to isolate y. To isolate y, let's add x on both sides. These cancel. -y is less than or equal to x minus 3. And we don't quite have y isolated. We have a negative in front of it, so we would need to divide by -1. Remember, when you multiply or divide, you have to do it by everything in the problem. These cancel and we get y. And then a couple of things are happening here that are really important algebraically. The first thing is, when you're working with an inequality and you multiply or divide by a negative, hopefully you remember from last chapter, you have to flip your sign. Absolutely have to do that. Okay, I have no idea where I was at because I just had to take phone calls. So if I didn't say it already, because you are multiplying, or in this case, dividing by a negative from the last section, you should remember your sign has to flip around. The other thing to remember is you're dividing everything by -1. So this becomes -x, and this becomes +3. Okay? Then it's the same as what we just did. You're going to start by plotting your y-intercept on your y-axis, and then counting your slope. What is your slope here? Don't forget there's a 1 here. It's -1. Down 1, right 1. Okay? Then you need to think about, how is an equation different from an inequality? First of all, what kind of line do you use? Because it has the equal to piece, you're going to use a solid line. Okay, make it extend in both directions. Okay, and then lastly, you need to figure out, where does the shading go? Where are the solutions? Because it's equal to, the points on the line are solutions, but those aren't the only ones. It's either going to be all of these points or all of these. I prefer to use a test point, so I would choose 0, 0 as my test point. When I plug that in, I get 0 is greater than or equal to, -0 would still be 0, plus 3 is 3. Is 0 greater than or equal to 3? No, that's not true. So if 0, 0 is not a solution, neither is anything else on this side. Everything on this side would be. If you want to really check your answer, pull off one of these points and check and see if it is a solution. It certainly should be. Okay, 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. So let's see if 3, 4 is a solution. That's the one I marked right here. Plugging that in, and you could even go back to your original one when you do your test point, and that's probably a good idea also to put it in there. 3, 4, you would have -3 minus 4. -3 minus 4 is -7. -7 is less than or equal to -3, so that works. Okay, the other way to do it, when it's in slope-intercept form, when your y is isolated, if it's greater than, you shade above the line. Okay? Two or more inequalities is called a system of inequalities. So back to the name of our section, it's called systems of inequalities. That's what a system is. It's when you have two or more of these things. All of the points that work for both inequalities will be your solution set. It's still going to be an infinite amount of solutions, an infinite amount of points, but it's going to be where the two shadings overlap. Okay, we're going to look at a visual representation. That's just fancy for looking at the graph. First one, it's in slope-intercept form, so we can go ahead and graph it. Go down 3, place a point. From there, you're counting your slope, up 2, right 1. And I'm going to do that a few times so I can get a nice, neat line. What type of line should I use here? If you said dashed, you are correct. Because it does not have the equal to symbol, we use a dashed line. Okay? Then you need to think about your shading. To figure out where to shade, use a test point. I like 0, 0. When I plug 0 in here, this whole piece would just be a 0. 0 minus 3 is negative 3. Is 0 less than negative 3? No, it's not. So we shade over here. When you shade on a system, do the first shading lightly, okay? And I'll talk about why in a second. Then, secondly, doing the second inequality, you're going to want to get that into slope-intercept form. Certainly, you could do a t-chart and do some values, but I think it's easier just to get it into slope-intercept form. Add x, negative y is less than or equal to x minus 3. And now here again, we have to divide by a negative 1. So that makes us flip our sign around. And you're dividing everything. So it becomes negative x plus 3. So our y-intercept is 3. Our slope is down 1, right 1. It's negative 1, down 1, right 1. Do a few of those. I could even go up 1, left 1 and stay in line. Okay. Solid or dashed line? Solid, because it has the equal to. Go ahead and sketch that in. Arrows on both ends. Ah, stop it. I don't want that. Okay, arrows on both ends. And we need to think about shading on this black line. Well, if I choose 0, 0 again as my test point, and I always can as long as it's not on the line, then I have 0 is less than or equal to. This would just be a 0. That's a 3. I'm sorry, I said less than. I should have said greater than. 0 is not greater than 3 or equal to 3. So I do not want 0, 0 as a solution. I want the other side of the line as the solution. Everybody with me on that, hopefully? So then, the solutions to this system of inequalities. System, again, just means two or more of these. The solution is the points that work for both. So where here are the points that work for both? It's where they overlap. Okay, so then you would want to go in and shade that part darker, and you want to go ahead and get rid of this part. So hopefully you're working with a pencil. Get rid of all this extra shading. You don't need it. It's just this area. Okay, right here. Again, don't get too close to the lines because I want to be able to tell if it's a solid or a dashed line. But this region, that is where your solutions are. Okay, that's how you do a system of inequalities. You graph two of them on the same graph, and then you want to see where they overlap. Okay, let's try this one. First, you want to get it into slope-intercept form. So I'm going to start by subtracting 2x on both sides. Negative y is greater than or equal to negative 2x plus 2. And again, I'm dividing by a negative 1, so my sign has to flip around. And I'm dividing everything, so I get positive 2x and negative 2. Negative 2 is my y-intercept. Positive 2 is my slope, so I'm up 2, right 1, doing that a couple times. Again, I can also go the other direction. Instead of up and right, I could go down and left, down to left 1. I need a solid line because I have the equal to along with the less than. I'm going to choose a test point of 0, 0. 0 is less than or equal to. This would be a 0, so I would have -2. Is this true or false? False. So 0, 0 is not a solution. That means my solutions are over here. Okay. You guys go ahead and pause the video. Do the second one on the same graph. Okay, so far I have put my inequality into slope-intercept form. I have graphed it. I decided to use a solid line because it has the equal to portion underneath it. And the last thing I need to do is figure out the shading. I used my test point and I got a true statement. So I want to shade the side that has the 0, 0, which would be underneath here. Okay, then I want to go ahead and erase anywhere where there's only shading on from one of the inequalities. So that would be right here, this section. I don't have the red shading, so I want to erase there. And over here, I don't have green shading, so I would want to erase there. Okay, so to make it a little bit easier to see, hopefully, let me use a third color. My shading is in this region. So you should go in with your pencil and darken this region. Hopefully that is what you came up with. Okay, so what's an inequality? It has a less than, greater than, less than or equal to, greater than or equal to. What's a system of inequalities? 2 or more of them that you're working with at the same time. Okay, a system is just 2 or more of these things, in this case inequalities. Where is the solution? Where are the solutions to a system of inequalities? It's where your shading overlaps. It's where they are both shaded. What I want to show you real quick is how to do this on your calculator. If you're watching this at home, you can try it in school tomorrow, or if you have your own calculator at home, you can use that. Okay, from your home screen, you want to go to graph. Whoops, sorry, I probably made a loud noise. B for graph. And then right here, you've got an equal sign. If you don't have this box up, by the way, if you don't have that, if you just have a graph, and if you have stuff on it, you can delete it by pressing menu, actions, delete all. Yes. Okay, if you're not in a standard window, like maybe you don't have -10 to 10, maybe you have some crazy numbers, menu, 4 for Windows Zoom, and 5 for Zoom Standard. Okay, so that's how to kind of get to a good starting point. Then to type in your inequality, you press Tab. And we don't want an equal sign, so we hit delete. And then there's all your inequality symbols. Now notice, f1 of x, remember, is the same thing as y. I think we talked about that when we started using the calculators at the very beginning of the year. So you need to be in slope-intercept form. Okay, in order to graph in your calculator, you have to be in slope-intercept form. Well, that's how we graph in when we're doing it by hand, so that's no big deal. So y is less than or equal to 2x minus 2. Okay, so less than or equal to is option 1. And then I'm going to type in 2x minus 2. And then I'm going to press enter. And whoa, look at that. Not only does it graph the line, it takes care of what type of line, in this case solid, and it takes care of the shading. So that was our green line with our green shading. Press tab again, and now we're going to just backspace again or delete again to be able to put our second one in, which is y is less than or equal to, so option 1 again, 1/2 x plus 1, so 1 divided by 2x plus 1, press enter, There's my second line. In this case, that was the red one. Again, it shows you the solid line and it shows you the shading. So it's pretty easy to see where the solutions are. It's in the darkest part of the shading. All right. So you can now do these in your calculator as well. I still want to see all of your work done by hand, but this is nice to be able to check your graphing in the calculator. But remember, the calculator is only as good as you are, so you have to be able to type it in there and do all of that work in order for it to know what to do. So the calculator is not magically going to give you answers. It will only be as good as you are at putting it in. Go ahead and explore that a little bit. You might want to try, go ahead and throw a third one in. This time I'm going to make it less than, I don't know, let's just do 3x plus 1. Hit enter, and there's a third one. Now, it's a little bit harder to see when it's clicked on here, but if you click somewhere else, then you can see, and especially if you mouse over it or use your little click pad here, you can see that it is actually dashed. All right, but when you first graph it, it's kind of selected and it's hard to see, so. Okay. All right, keep working on your packet.